Good afternoon, good morning, good evening, depending on where you're watching from. Today, I'll be talking about graphing techniques. Uh, why I'm talking about these graphing techniques today is because of the challenges we have witnessed so many students having issue in plotting graph, yes, especially in physics exams or in physics class, especially when practical is being carried out. You see students having issue like by trying to scale a graph is a very big problem for students today, not only in secondary school, even in university settings. So I'm bringing these graphing techniques to teach students that want to embark in one exam or the other to know how these graphs are being plotted. And in plotting graph, you have variables. The two variables must be a kind of a relation. We want to check the relationship between two variables. What is the relationship between two variables? Well, and that graph line that you see is something that we assume to be in constant position. So if you are plotting a graph, that is an information you are trying to achieve from graphical representation, and that is trying to get relationship between two things, and how are these things relating to each other. Is this one increasing while this one is decreasing, or is this one decreasing while this one is increasing, or is there no relative variation in those two quantities? So in that area, when we try to ascertain the variation in quantities or variables, you are trying to represent them in visual form. That is why we have graphing and graphing techniques. Now, what is a graph? A graph is a visual representation of data or relationship between variables, often using lines, points, or trends and correlations. Now, you can see that in graphing or graph, you must always use line, you will use points to identify some relationship between two quantities or two variables. From this point to this point, when this one is here, where will you locate this one? So you are trying to get position as it relates to the point where, in fact, you call it the reference point, where you can say, okay, if this thing is standing here, where will I get the other one? So at that point, you have to identify the point, the location where you can, let's say, where you can, there is a let's say a point of intersection between two quantities. That is the relationship between the two quantities. Where do we get them? Now, on that note, now we are trying to work on the graphing techniques. And what is graphing techniques? It is a method used to effectively create, interpret graphs perfectly, and this include what? It includes choosing the right graph, line graph, bar chart, scatter plot, labeling axis and adding, scaling and formatting. These are the things. Now, we don't want to go into much detail for now. I also want to give you the brief understanding of this graphical representation. So when we talk about this in detail, just like I want to go into the practical properly, I will address these issues and try to fix them according to how you understand how this graph are being achieved. Just you can see there are some points here in this. There are some points. Just like watch this point. These are the points. These are points here. You watch this point. You see these points. These are points. So these points is trying to identify the relationship between two variable. Like for this point, you can see that when it is at 0, there is a quantity here. When this is at 0, when this is at 20, there is a relationship between this line and this line. There is a relationship between this line and this line. There is a relationship between certain lines in these quantities. So that is why we try to expatiate on this area, trying to get some facts. It is very, very important. It's very, very important. In as much as we are trying to get this, we are evening. We try to fix this one, get it being dollarized. Okay, let's say this is a distance is plotted against time. Distance against time in seconds, and this is distance. So you can see that we're having 0, 20, 40. Sorry, you have 0, 20, 40, 60, and all the other things. So in that area now, sorry, we just go back. Let's get back to this point. We're not trying to extract. Let's go back. So we have 20. So you can see that this is a scaling pattern. It's a scaling pattern. Now look at this. We have 0.1. We have 0.2, 0.3, 0.4. What is this trying to tell us? If you have a table, we can say that when this is 20, when you have 20, so the scaling of this graph is that we are scaling. If we say from this point now, let's say from this point here to this point is 20. And let's assume that if we are using your rule to measure from here to here, we assume that here is 2 cm. We are assuming, we are not saying that this is 2 cm. We just assume that if from here now, from this point to this point is 2 cm. Then that means if here to here is 2 cm, that means from here to here should be a what? 4 cm. That is the scaling pattern. Then from that, if we here now from here to here is 2 cm, from here to here now, from here now to this place, from here to this place now should be another what? 2 cm. So that is how the graph is. Now from here, if from here to here, let's say now from here to here, let's say from here to here is 2 cm. From here to here is 2 cm. Is 2 cm. Then from here to here also is another 2 cm. Then from here to this point should be 4 cm. The same thing applicable to this place. From here to here, if from here to here is 2 cm. Then from here to here another 2 cm. Then from here to here now should be 4 cm. Then in terms of scaling this kind of graph, instead of scaling it, you try to understand the scaling pattern. Now, what is the scaling pattern here that is involved? The scaling pattern that if from here to here is 2 cm, that means this is 20. This one here is 20. I will call it 20 units. Then here should be what? That means here should be 40 units, 60 units. Then this thing is increasing by 20. That means from here to here is 20. Then we add extra 20, giving you 40 here. Another 20 again, giving you 60. So you are increasing the scale now should be 2 cm. Since here from here to here is 2 cm, then you are adding 20. So the scaling here is 2 cm to how many units? 20 units. 2 cm to 20 units in the distance axis. Then if from here to here is 20, here 20, that is adding by 20. So it becomes 2 cm to 20 units. That is the scaling. The same thing here is you can see that this is adding 0.1, 0.1, 0.1. So if this is 0.1, from this point to this point now is 2 cm. From here to here is 2 cm. But from here to here is 0.1. That means another 0.1. 0.1 plus 0.1 will give you another, will give you 0.2. That means the unit here is 0.1. That means every 2 cm you add what? 0.1. So the scale in this time axis becomes 0.1 in time axis to what? That is 0.1 unit. Sorry, 2 cm. 2 cm. That is what I'm talking about, the time axis. That is 2 cm represents 0.1 unit in the time axis. That is 2 cm. From here to here is 2 cm. We assume that it is 2 cm. That means if from here to here is 2 cm and from here to here now is 0.1, that means it becomes 0.1 unit in what? 2 cm represents 0.1 unit in the time axis. So if you keep doing it like that, you can see that in graph paper, graphs that are intended to provide numerical information should always be drawn on a square or cross-sectional graph paper, which is 1 cm times 1 cm with 10 divisions. Now, let's not go into that place. And also, you need to know the title of your graph. Titling of graph is very, very important. And look at the choice of scale. That is where you can choose your scales. Scales should be chosen in such a way that data are easy to plot and easy to read. On coordinate paper, every 5th or 10th line is slightly heavier than other line. Such a division line should what? Now let's look at into this. For example, now we have 0, 1, 2, 0.05, 20, and others. So what I'm trying to address here is this. And I will carry out this explanation practically, where I'm going to address how this case has been chosen. So I just want to give you some outlines that we have a way of interpreting scales, and what is called a straight line graph and curve graphs. As you can see, this is straight line fittings. This is a straight line fitting where you have the graph is always in a straight line. There are some graph you plot, it will be in the there will be a curve graph. Like this one, I can see this is a straight line graph. This is a straight line graph. So these straight line graphs are always there to show that this graph is very straight. Look at it, it's a straight line graph. There are some graphs that will be curved like this. And in the graph, you have to understand what is also called sloping. So sloping will always come like this, sloping. You know how to slope a graph. you sloping. Sloping is very, very important. In slope, after you plot a graph, the next you need to understand is the slope, which we always get like this. This is the slope in a graph. This is the line of the graph, and this is the slope. So the slope also gives you the let's talk about a constant value of the two variable. Let's say this is distance d and this is time t. So when we talk about this now, the distance and time, so we're talking about this slope defines the velocity or the speed. This slope here gives you the what? This graph is talking about the distance, sorry, the velocity or the speed, and also the slope here defines the value of this velocity or the speed. So when we go into this, you understand how this graph are being plotted. So I would like you to watch the next video where I'll be addressing how this graph are being addressed, how you can plot this graph, the techniques, the step-by-step approaches in order for you to achieve a perfect graph in any exam you are writing, so that you will not be saying, how did this person get this one, how did this one come into. Some people, they even give them graph to analyze, they cannot even analyze the graph because what, they find it very difficult to understand the scaling. Immediately you understand the scaling in graph, you are done with the job. Just understand the scaling, everything is just done. I want to tell you that after my class with you on how graph are being managed, I bet you that you will never have issue plotting graph. Thank you. Please like this video, share with your friend. Make sure you watch the next video, and don't I say don't watch alone. Try to share with your friend. Make sure you subscribe, hit the like button, and comment. Ask questions in the comment section. I've seen some people watching, but they're not asking questions. They're not doing anything. They are just viewing. I know that people that are viewing, they are also doing great, but I want you to comment, like, and share so that other people also benefit from this class. Thank you. Thank you very much. Thank you for watching. Thank you for coming online. So view it and see how these things are done. Thank you very much.